Right, in today's lesson, we are going to learn how to find the area of composite figures that are made up of semicircles and quarter circles. Okay, the first strategy that we're going to use is adding the areas of the shapes that make up the composite figure. Okay, let us look at the first example. In the first example, we have a figure that is made up of a quarter circle here, ACD. Okay, so this is a quarter circle, right? It's a green quarter circle with a radius of 12 centimeter, right? And it is also made up of a semicircle ABC. Okay, let us put a semicircle here. Okay, then as you can see, the diameter of this semicircle, blue semicircle, is 12 centimeter. Okay, so in other words, this composite figure is made up of two shapes, the green quarter circle as well as the blue semicircle. So to find the area of the figure, it is the same as finding the area of this green quarter circle with a radius of 12 centimeter and finding the area of this blue semicircle with a diameter of 12 centimeter. And then what we do is we add the area of these two shapes together to find the area of the whole figure. Okay, let us find the area of the green quarter circle first. So area of green quarter circle is equals to, okay, since we are talking about quarter circle here, the formula will be 1/4 multiplied by the formula to find a full circle, which is pi multiplied by radius multiplied by radius. Okay. The value of pi is given as 3.14 as given in the question, and then the radius here, alright, let us go back and refer to the quarter circle. The radius is 12. So multiply by 12, multiply by 12. Okay, so if we simplify here, so this is same as 3.14 multiplied by 36. Okay, we take 3.14 multiplied by 36. The answer we're going to get is 113.04. So this is 113.04 square centimeter. Okay, so let us write down the area here, 113.04 square centimeter. Okay, next we're going to find the area of this blue semicircle. Okay, area of blue semicircle will be equals to half. Okay, we are talking about semicircle here, so the fraction in our formula will be half multiplied by pi multiplied by radius of the blue semicircle multiplied by radius of the blue semicircle. Okay, so this is to differentiate from the radius here. So it will be half multiplied by 3.14 multiply by, okay, if we look at the blue semicircle, the diameter is 12 centimeter. That means the radius will be 6. Okay, then we simplify here, so your answer will be 3.14 multiplied by 18. Okay, 3.14 multiplied by 18. And that will give us an answer of 56.52. Okay, that will give us area of 56.52 square centimeter. Okay, let us write the area on this blue semicircle. So the area of the figure will be, we take the area of the green quarter circle, add to the area of the blue semicircle. Okay, and what does that give you? 113.04 add to 56.52, and that will give us the area of 169.56 square centimeter. Okay, so this is the area of the figure that we are going to find. Okay, the next strategy that we are going to learn to find the shaded area in a composite figure is by subtracting the unshaded part from the figure. Okay, let us look at the example here. In this example, we have A, B, C, D, which is a square of side 14 cm. B, C, D is a quarter circle with a radius of 14 cm. And we are supposed to find the area of this shaded part here. So how do we find the area of this shaded part? Okay, to get this shape here, sometimes we call it the party hat, sometimes we call it the L brackets. Okay, what we have to do is, we started from a square piece of paper. Okay, it's the same area as square ABCD. Then what we are going to do is that we are going to cut a quarter circle out from the square. Okay, and whatever is left here, okay, after we have cut out the quarter circle from the square, whatever is left here is the area of the shaded part that we have to find in this question. Okay, so if we cut away a portion of the square here, this is the same as subtracting the area of this part that we have cut off. So since we have cut off an area that is equivalent to the quarter circle, to find this part here, we take the area of the square to take away the area of this quarter circle. So first step we are going to do is to find the area of the square. Okay, so area of square will be length multiplied by length, so it's 14 multiplied by 14. That will give us 196 square centimeters. Okay, the next we are going to subtract the area of this quadrant from the square. So area of quadrant, a quarter circle, is equals to, alright, we are talking about quarter circle here, so the formula will be 1/4 multiplied by pi multiplied by radius multiplied by radius. Okay, pi is given as 22.7. Okay, and the radius of this quarter circle is 14 centimeters. Simplify our fractions. Okay, and what we have here is 11 multiplied by 14. Okay, so if we take 11 multiplied by 14, that will give us 154 square centimeters. Okay, so in our third step to find the shaded part, what we are going to do is we take the area of the original figure or the whole figure, which is actually the square, and then we subtract the shape that we have cut off, which is the quarter circle, from it. Okay, so that will give you 42 square centimeters. So that will be the answer for finding the area of this shaded part. Okay, the green part in this composite figure. The next strategy that you're going to learn to find the area of the shaded parts in a composite figure is by shifting the shaded parts such that it will form a shape that you're familiar with. So let us look at this question. Okay, in this question, PQRS is a square of side 20 centimeters. Then we have PTQ here, which is a semicircle, and then we have another identical semicircle, QTR. Okay, so these two semicircles intersect, and this is the overlap area of the two semicircles. We are supposed to find the area of the shaded parts, which consists of the blue shaded part here and another blue shaded part here. Okay, now the easiest way to find the total area of the blue shaded parts is that I'm going to remove this. Okay, before I remove this, let me cut this. Okay, we call it a petal, into halves. Okay, this is known as the petal, the shape of a petal. So we're going to cut the petal into half. Okay, I'm going to remove it from here. So what I'm going to do is I'm going to cut this into halves. Okay, then I'm going to place this half over here. Okay, and I'm going to place the other half over here. Okay, and after that, I'm going to draw a line from P all the way to R. Okay, so you can see that the total area of the shaded parts, that means the blue parts here, actually form half of the square. So to find the area of the shaded parts is the same as finding half of the area of the square. Okay, so let me repeat what I have done. Okay, originally the shaded parts were like that. Okay, so it consists of this part here and the petal here. So what I did was to cut the petal into halves. Then I will put one half over here to fill up the space. Let me extend the line here so that you can see better. Okay. So what I did was to put one half of the petal into here to fill up the shaded part there, and then I put the other half of the petal over here. So when I did that, I combined all the blue parts together, and you'll notice that the blue parts actually form half the area of the square. So to find the total area of the shaded parts, is the same as finding half of the area of the square. So the area of shaded parts is equals to half of the area of the square. So the area of the square is 20 multiplied by 20. Okay, and that will give us 200 square centimeters. So by shifting the area of the shaded parts, we can find the total area of the shaded parts in only one step.